transient voltage surge suppressor, TVSS, is fundamentally a protective device, not a load in the traditional electrical sense. Its primary function is to safeguard sensitive electrical equipment by intercepting and diverting transient voltage spikes. While a TVSS doesn't behave like a typical load such as a motor or lighting fixture, it does require a dedicated circuit breaker for its operation and protection. This circuit breaker provides the necessary power to the TVSS and protects it from overcurrent conditions. In a setup like the one described, where there are 6 circuit breakers including one specifically for the TVSS and no main breaker, this is a common configuration for smaller switchgear applications. It is important to consider that if multiple TVSS units are employed, they should ideally be installed on separate circuits. This prevents the potential overloading of any single circuit due to the cumulative power draw of the TVSS devices. There are several recommended practices to follow when installing a TVSS in switchgear. Firstly, install the TVSS as close as possible to the service entrance. This maximizes its effectiveness in intercepting surges before they can propagate through the electrical system. Secondly, use a dedicated circuit breaker with an appropriate rating for the TVSS. The breaker rating should be selected based on the TVSS manufacturer's specifications to ensure proper protection. Thirdly, connect the TVSS to a ground rod. A good grounding connection is crucial for the TVSS to effectively divert surge currents to ground. Fourthly, consider installing a surge counter to monitor the number of surges the TVSS intercepts. This provides valuable data on the frequency and severity of surge events, which can help in assessing the performance and lifespan of the TVSS. The purpose of the TVSS is to clamp voltage spikes to a safe level, protecting downstream equipment from damage. It achieves this by diverting excess energy to ground. A TVSS operates by monitoring the voltage on the electrical line. Under normal conditions, it remains in a high impedance state, effectively invisible to the circuit. When a transient voltage spike occurs exceeding a predetermined threshold, the TVSS rapidly switches to a low impedance state, providing a path for the surge current to flow to ground. The TVSS then returns to its high impedance state once the surge has subsided. The selection of a TVSS involves several key considerations. 1. The voltage rating of the TVSS must be compatible with the system voltage. In the described scenario, a 208-volt system requires a TVSS rated for 208 volts or higher. 2. The surge current capacity of the TVSS should be sufficient to handle the expected surge levels. This is typically specified in kiloamps Ka. 3. The TVSS should have a low voltage protection level, volts protection rating, or volts let through voltage. This indicates the maximum voltage that the TVSS will allow to pass through to the protected equipment. A low volts protection rating provides better protection. 4. The TVSS should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. Proper installation is critical for ensuring the TVSS functions correctly and safely. It's important to understand the different types of TVSS devices available. There are Type 1, Type 2, and Type 3 TVSS devices, each designed for different applications and locations within an electrical system. Type 1 TVSS devices are typically installed at the service entrance, providing protection for the entire facility. Type 2 TVSS devices are installed at distribution panels or subpanels, providing protection for branch circuits. Type 3 TVSS devices are installed at or near sensitive equipment, providing point-of-use protection. The choice of TVSS type depends on the specific protection requirements of the application. Surge protection is essential for safeguarding electrical equipment from the damaging effects of transient voltage spikes. These spikes can be caused by a variety of sources, including lightning strikes, utility switching, and the operation of electrical equipment within the facility. Without surge protection, sensitive electronic devices are vulnerable to damage, which can lead to equipment failure, downtime, and costly repairs. The proper installation and maintenance of TVSS devices are critical for ensuring their effectiveness and longevity. Regular inspection of TVSS devices is recommended to check for any signs of damage or degradation. Surge counters, if installed, should be monitored to track the number of surge events. TVSS devices have a limited lifespan and will eventually need to be replaced. The lifespan of a TVSS depends on the frequency and severity of surge events. A TVSS is not a load, it is a protection device. The sizing of the circuit breaker for the TVSS should be based on the TVSS manufacturer's specifications. This typically involves considering the TVSS's continuous current draw and its inrush current. The circuit breaker should be sized to handle the inrush current without tripping while providing adequate protection against overcurrent conditions. Grounding is crucial for the proper operation of a TVSS. The grounding conductor should be as short and straight as possible to minimize impedance. A low impedance ground path is essential for effectively diverting surge currents to ground. The National Electrical Code, NEC, provides guidelines for the installation of TVSS devices, including requirements for grounding, bonding, and overcurrent protection. Adherence to the NEC is essential for ensuring the safety and effectiveness of the TVSS installation. When selecting a TVSS, it's important to consider the specific requirements of the application, including the voltage level, surge current capacity, and protection level. Consulting with a qualified electrical engineer or TVSS vendor can help in selecting the appropriate TVSS for the application. TVSS technology has advanced significantly in recent years, with the development of more effective and reliable surge suppression devices. These advancements include improved clamping performance, higher surge current capacity, and longer lifespans. Staying up to date on the latest TVSS technology can help in selecting the best surge protection solution for a given application. A TVSS is a critical component of a comprehensive electrical protection system. It works in conjunction with other protective devices, such as circuit breakers, fuses, and ground fault circuit interrupters to provide complete protection against electrical hazards. The TVSS is part of a layered approach to electrical protection. Proper coordination of these protective devices is essential for ensuring the safety and reliability of the electrical system. In summary, a TVSS is not considered a load, but a protective device that requires a dedicated circuit breaker for its operation and protection. Proper installation and maintenance are essential for ensuring its effectiveness and longevity. Following recommended practices and adhering to the NEC are crucial for safe and reliable TVSS installation. The TVSS should be installed as close as possible to the service entrance to maximize its effectiveness in intercepting surges before they can propagate through the electrical system. The dedicated circuit breaker should be of the appropriate rating for the TVSS as specified by the manufacturer to ensure proper protection against overcurrent conditions. Connecting the TVSS to ground rod is crucial for effectively diverting surge currents to ground, and a surge counter can be installed to monitor the number of surges the TVSS intercepts, providing valuable data on the frequency and severity of surge events. The selection of a TVSS involves considering factors such as the voltage rating, surge current capacity, and volts protection rating to ensure it meets the specific protection requirements of the application. Different types of TVSS devices, such as Type 1, Type 2, and Type 3, are designed for different applications and locations within an electrical system, and the choice of TVSS type depends on the specific protection requirement. Surge protection is essential for safeguarding electrical equipment from the damaging effects of transient voltage spikes, which can be caused by various sources. Regular inspection and maintenance of TVSS devices are important to check for any signs of damage or degradation, and surge counters should be monitored to track surge events. The circuit breaker for the TVSS should be sized based on the manufacturer's specifications, considering continuous current draw and inrush current, while grounding is crucial for proper operation, with the grounding conductor kept short and straight to minimize impedance. Adherence to the NEC is essential for ensuring the safety and effectiveness of the TVSS installation, and consulting with qualified professionals can help in selecting the appropriate TVSS. TVSS technology has advanced, offering improved performance and reliability, and a TVSS is a critical component of a comprehensive electrical protection system, working with other devices for complete protection.